Okay, let's work on it. Let's work on it. Let me try to show you something. Okay, so when we're discussing the probability, you have to understand that probability is the numerical measure of the likelihood or chance that an event will happen or not happen. When we talk about probability, we talk about the numerical measure of the likelihood or a chance that an event will happen or not happen. So an event refers to an activity. Then outcome refers to the result of a trial. Then trial is the act of letting an event happen or not happen. Example, action of tossing a coin. So chance refers to a possibility of something happening, while possible outcomes is the chance that the event will happen. When we talk about the possible outcomes, we talk about the chance that the event will happen. When we talk about the impossible outcome, this is no chance of the event happening. So certain refers to something is definitely going to happen. There is no way it is not going to happen. It is 100%. So likely refers to the chance of something happening is greater than the chance of it not happening. So unlikely, this is chance of something happening is less than the chance of it not happening. It refers to the chance of something happening is less than the chance of it not happening. So even, which is 50-50, the chance of something happening or not happening is the same. It might happen or it might not happen. It's 50-50. So prediction, this is a statement describing the chance of an outcome to happen based on the given information. Then tree diagram is a diagram using branches to display all the possible outcomes of the event. Okay, so let's look at the following visual representation of the probability scale. Take a look here. As you can see, here we have impossible. I told you that impossible shows that the chance of something happening are very low. There's no way it can happen, meaning it is 0%. So 25% of a chance happening is unlikely, while 50% is EV. This is equally likely to happen or not happen. So 75% is likely to happen, while 100% is certain. 100%. There's no way it cannot happen. So let me try to erase here so that I can give you some examples. Then we're gonna see where those examples are going to fall. Okay, here are the examples. State the probability of the following events using the probability scale. So flipping a coin to land on tail. You must know that a tail or a tail or head, the coin has only two possibilities. Either it is tail or either it is head. So the chance of it happening is 50%. It's 1/2. The chance is 1/2. Flipping a coin is 1/2. So the sun setting in the evening. The sun setting in the evening, that's 100%. The sun will set in the evening. So it's 100%. That's 100%. It's EV, setting. This is setting. So pigs flying, the chances of pigs flying, that's 0%. That's impossible. Impossible. I believe you understand that one very well. The chances of pigs flying is here. It's impossible. It's 0%. The chances of flipping a coin is 50%. Equally likely to happen or not happen. The chances of the sun setting in the evening is certain. It's 100%. Okay, let's go to example number 2. For example number 2, they say a jar contains 7 red balls and 12 blue balls. Determine the probability of picking a red ball. If There are 7 red balls. There are 7 red balls and there are 12 blue balls. What is the probability of picking the red balls? There are 7 red, 12 plus 12 blue. The total here is 19. So there are 19 there. So what are the chances of picking up a red ball? There are only 7 red balls out of 19. So that's the probability. 7 over 19. The probability of picking a red ball is 7 out of 19. So example number 3. A dice is thrown and the outcome is noted. Determine the probability of throwing a 3. 3, you must know that in a dice, we have 1, we have 2, we have 3, we have 4, we have 5, and we have 6. So the chances of throwing a 3, it's only 1. 1 out of 6. That's the chance. The chances is 1 out of 6. So the chances of throwing an odd number, we only have 3 odd numbers. So it's 3 over 6, which equals to 1 over 2. Even numbers, we have 3 out of 6, which is 1 out of 2. That's how you work it. It's very much simple for you to understand this one. Okay, let's check here. This is example number 4. Example number 4. Okay, a standard deck of cards is made out of 13 spades, 13 hearts, 13 diamond, 13 clubs, as indicated below. What is the probability of that Poppy will pick up a queen spade? Let's check on queens. Let's check on the spades. Okay, yeah, it is. We have this one here. This one here. The chances are 1. 1 out of the total. It's 1 out of 52. Those are the chances there. 1 out of 52. So number 2, Nikiwe decides to pick a card from the deck while Poppy is holding the queen of spade in her hand. What is the probability, okay, as a decimal, that Nikiwe will pick a queen from the deck? The queen from the deck. Let's check on the queens here. Let's check on the queens. Let's check on the queens. We have this one. We are not going to count the one that Poppy is holding, which is this one. So we'll take this one, which is now will be the number 1, and this one will be the number 2, and this one will be the number 3. So we only have 3 out of 51. Here the solution, as you can see here. So as a decimal, 3 out of 15 equals to 0.06. The first one is 1 out of 52. The second one is 3 over 15, 1, which is 0.06. So let's discuss this one here. Okay. Let's talk about the tree diagram. The tree diagram. So a tree diagram is shaped like a tree. It has branches that represent the possible outcomes. A tree diagram is a visual way of expressing the outcome, particularly when there are more than 2 events. So let's work on example 1. Draw a tree diagram to represent the possible outcomes of tossing a coin 2 times. Tossing a coin 2 times. Here are the possibilities. Coin tossing, first toss, tail and head. Second toss will be tail head, and here on the head will be tail head. So the outcomes is TT, TH, HT, HH, meaning tail, 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 head, tail, head, head. So they say state the number of possible outcomes in the tree diagram. There are 4. 1, 2, 3, 4. So those are the outcomes there. Determine the probability of getting the following: one head, a tail in order, two heads. As you can see here, one head, a tail, one head, a tail. And they said what? Two heads. You can see it's 1 out of 4, 1 out of 4, as you can see from there. It's only 1 out of 4, 1 out of 4. So as you can see from here, when you are about to complete, they say complete this tree diagram. If they say to complete this tree diagram, as you can see here, they are talking about matches. They are talking about matches, as you can see from there. Okay, it's WLD. This is very much simple. So as you can see from this line, they say WW, then L, then D. WW, WL, WD. So from here, it will be WL, D, which here will be L, W, here will be L, L, here will be L, D. Then from the last one will be L. Sorry, let's start with W. We start with W to avoid confusion. It will be W, then L, then D. Then it will be D, W, it will be D, L, then it will be D, D. I'm doing this because I want to save time. I'm running out of time. So that's the reason why I am running.